Good morning, learners. Let us now start with the remaining part of this NumPy library, statistical methods, sorting, and set operations. Now, let us see initially about some basic statistical operations. Now, if you wanted to create a matrix of random numbers with given dimensions, then you can use rand_n. Rand_n will generate random numbers with the given dimensions, and that too according to a normal distribution. So you wanted to generate some sample according to normal distribution. Then you can use this rand_n. Say if you want the numbers according to a normal distribution, the curve may be like this, right? This indicates normal distribution. What does a normal distribution mean? Now, if you take the example of students in a class and you take their weights, right? So the number of students having very less weight and the number of students having extreme weight will be very less, but most of the students' weights will be around some average, right? So this is called as normal distribution. Now, if you want to generate numbers according to a normal distribution, then you can use this rand_n. Now here we are requesting NumPy library to create a matrix of the shape 2 by 5, means 2 rows and 5 column of random numbers, and store it in the array object and print that object. So when you execute this, you can see the random numbers being generated here with the given dimensions, and you can observe that they are according to a normal distribution. You can try to plot a graph with this. You will find that they are generated according to a normal distribution. Now, if you want to find the mean of all these numbers, then you can use the method mean. Sometimes when you wanted to understand the dataset characteristics, say you're given a dataset to analyze, initially you have to do this while pre-processing the data, right? Whenever you have to fit some machine learning model to the data, initially you have to pre-process the data. When you're pre-processing the data, you need to understand about the characteristics of the data. Now, what is the average value under a given feature or parameter, and what is the spread of the data, what is the standard deviation in the data, what is the variance in the data, what is the central tendency of the data, right? All these will give you some preliminary idea about the characteristics of the data, which will actually guide you further in order to pre-process the data more efficiently so that you can fit very good machine learning models with that data. I already mentioned that garbage in, garbage out concept will be garbage in, garbage out concept is seen when the data is not properly pre-processed, right? If you put the garbage in into a machine learning model, you'll get unreliable results. So you have to pre-process the data very efficiently, and in order to do the task effectively, you have to first understand about the characteristics of the data. For that, we need to find out what are the basic statistical operations you have to perform on the data. What is the central tendency of the data, spread in the data, variance in the data, right? For that, initially, we are using mean here. Mean is a method which will help us to calculate the average of all the values in this matrix. So when you print this array's mean, all these values average will be calculated and it is printed. So as I pointed out to you in the curve, in the bell curve, the middle point, that middle point will be indicated by this number, the average of the matrix, the average of the values in the matrix given here, 0.34. Right? Now, if you want to calculate the average along the rows or along the columns, then you have to add some additional parameter here by using axis. Axis equal to 1 indicates that you want the mean across the rows, right? So when you click, when you execute this, you can get the mean of the first row as 0.54 and mean of the second row as 0.14, right? This is how you calculate the mean of each of the rows in the matrix. Now, if you want to calculate the mean of columns in a matrix, then you have to change the axis number to 0. When you execute this, you can get total 5 values because you have 5 columns here. The first column, second column, third, fourth, and fifth column. Each of those columns, the mean is calculated. Mean of these first two numbers, mean of the second two numbers in the column, the next two numbers in the column, and so on, right? So that will give you the mean for each of the column. Now, if you want to get the sum of the elements across the rows, then you can use sum method with axis equal to 1. So it will give you the sum of all these values as the first element in the result and sum of all these values as the second element in the result. That is given here. Okay. Now, if you want to calculate the median, median is arranging the elements in the ascending order and taking the midpoint if there are odd number of values and taking the average of midpoints if there are even number of values, right? That is the median. Now, if you want to calculate the median of the array, then you can use np dot median. Notice the difference here. We are using np dot median. We are not applying the operation sum like in sum on the array. You are applying it by using the np libraries method, right? np dot median, and on which array or on which matrix you are applying the operation ARR, and along which axis you are applying, you want the median of all the row values. So you are giving it as all the column values. So you give it as axis equal to 0. When you execute this, you get the median of the first column, second column, and so on. Now, if you wanted to sort the values in the matrix, then you can use the sort function or sorted function. If you don't want the original values to be changed, then you can render the matrix in a sorted order by using sorted. But if you want the original values to be sorted, then you can use the sort method along with the list. This we have discussed in the previous videos also. Now here we are generating one-dimensional array. You can notice here it is enclosed between single brackets, right? Now when we are enclosing this within single brackets, we call this as rank 1 matrix. Now if two brackets enclose a list of values, then we call it as rank 2 matrix. Means one-dimensional matrix and two-dimensional matrix. Now we are creating total 10 numbers in an array. So we are using rand n, and we are giving the dimension as we are just passing one dimension, which indicates that we are interested to create one-dimensional one-dimensional array. So that array with random numbers is created and it is stored in an object called as unsorted. When you print this, you can notice that a one-dimensional array with random numbers are generated, and remember these numbers are according to a normal distribution because you are using the rand n method. You have already used random int method, random method, which will generate random method will generate numbers between random numbers between -1 and +1, and rand int will generate random integers within a given range. Here we are using rand n to generate random numbers according to a normal distribution. Now, when you display that, now you are just converting it into an array. Here you are using np.array and you're creating that list. You're transforming that list into an array, and on that array you're applying the sort method. Now, when you print the sorted value and the unsorted value, you can notice the difference here. In this case, in the first case, you get all the elements in the sorted order, but if you print the original value, it will still be printed as unsorted because you are saving here it in a different object and applying sort on that object. but not on the original list. That is why you are getting the same array without any sorting. But when you print this sorted list, yes, you get all the elements in the sorted order. Now, when you apply this sort method on unsorted list itself, then you can see that all the elements uh, are sorted. The original elements in the one-dimensional array are sorted. Now, if you want to find unique elements, say you're working with real-time data set, which has columns that has redundant values, but you just wanted to know that over which values which are unique in that column. I'll give you an example. Say you have some countries' data, some geographical development indicators. You have like literacy rate or mortality rate or male-female ratio. This kind of data is being collected across various countries. In that case, country name will be repeated for each of these parameters, right? For each of these measurements. Now, this data has been collected, you have to get the unique list of the countries. Though the parameters for each of the countries are making the country name repeated. I'll give you an example here. Say if you have country name and male female ratio and country name literacy rate and again country name gross domestic product, right? GDP. Now again these things are calculated, measured for Bangladesh also, male female ratio, and say it is recorded for Maldives also, say literacy rate and again gross domestic product, right? Now under this country column, I wanted to know from how many countries the data has been captured. Now, if I count the number of data points under this column, I totally get 6 values. But across how many countries the data is originally captured? Only 3, right? So I wanted to get the unique values from this country parameter or country feature. So this will give me India, one unique value. This will give me Bangladesh and this Maldives, right? So total across 3 countries, these geographical growth indicators are calculated. For that, if you wanted the unique values under a particular column, how you can do that? By using the unique method. You can use this unique method. In this array, you can see that most of the values are repeated. Now, when you use np.unique method on this array, you can see that only the unique values are displayed. Right? This is how you can retrieve unique values from a column which is having redundant values. Now let's see how to perform set operations with NP array data type. Now let us create 2 sets of values by using np.array. Here this is array of strings which is taking 3 values, desk, chair and bulb, and this is being saved in object S1, and another array lamp, bulb and chair which is being saved in S2. Now when you try to print these 2 elements, you can see the list being displayed. Now, if you want to find out which are the elements that are common to both the arrays, in that case you can use intersect 1D. Intersect 1D is a method that belongs to the NumPy library, which will display the common elements in both S1 and S2. So what are the common elements here? Desk is not there, chair and bulb. Yeah, chair and bulb are the common elements. So those are being displayed here. Now, if you want to find out the union of these 2 sets, Union of these two sets means all the values in both the sets but without any repetitions. That will be given by union 1D. So when you execute this, you can see bulb, chair, desk and lamp are displayed without any repetitions. Now, if you wanted to get the values that are in S2 which are not in S1, generally, we denote it as S2 minus S1 or S1 minus S2. S1 minus S2 indicates elements existing in S1 which are not in S2. Okay, that will give us the set difference. So here occur in S1. What are such elements? Lamp. Now, if you change this to S1 and S2 and display, you can get desk which occurs in S1 that doesn't occur in S2. This is how you find the set difference by using set difference 1D. Now there is another kind of method called as in 1D which will give us which element of S1 is also in S2. Sometimes you may be interested to find what are the elements that are existing in this particular column is also appearing in the other column having the same data type and the same characteristics. In such cases, you can give in 1D what it gives what elements are there in S1. If they exist in S2 also, such elements will be retrieved into the result. Now you can see here it is giving us Boolean values. Such elements means the Boolean values of those elements will be displayed. Now initially what desk is there in S1 but it is not there in S2. So it is giving us false. Now chair is there in S1 and it also appears in S2. So it is given as true. Now bulb is there in S1 and it is also available in S2. That is why it gives true here. This is how the set operations work. Now let us see another important concept of this NumPy library is broadcasting. Broadcasting will help us to perform addition between different kinds of dimensions. I'll give you an example. See, normally when you want to add two matrices, you want them to be in the same dimensions, right? Say there is a matrix A and matrix B with elements 1, 2, 3, 4 and 7, 2, 9, 1 like this. Now, if you want to add these elements, you can add them easily. A plus B. If you want to add these two matrices, you can add them. 1 is added to 7, 8. 2 is added to 2, 4. 3 is added to 9, it is 12. And 4 is added to 1, is 5. Right? This will be the result. Now, if I have a matrix like this, 1, 2 and another matrix like this 7 2 9 1. Now matrix addition has some rules, right? They both have the both matrices have to have the same dimensions, but in this case they doesn't have same dimensions. Here it is 1 by 2 matrix and here it is 2 by 2 matrix. We can't add these two matrices, but through broadcasting technique we can perform such operations. Now this broadcasting technique will enable us to broadcast this row to this row and to this row as well. Now according to broadcasting, this 1, 2 will be added to this row and same 1, 2 will be added to this row also. So when you perform the addition, then 1 is added to 7 which will give you 8, 2 is added to 2 which will give you 4. Again 1 is added to 9 that gives you 10 and 2 added to 1 that will give you 3. This is how broadcasting is done. Now this is broadcasting across the rows. Now if you want to broadcast it across the columns, say you have the same matrix 1 and 2 and B you have 7, 1, 8 and 2. Consider this is another set of matrix you have. Now you want to broadcast 1, 2 not across the rows but across the columns. Then you have to just find out the transpose of this matrix, which will give you 1 2. Now this 1 2 is broadcasted to first column and second column also. So when you add these two matrices, you give 7 added to 1 8, 8 added to 2 10, 1 added to 2 2, and 2 added to 2 4. This will be your result. So this broadcasting happened to the columns. In the previous case, broadcasting happened to the rows. Right? This is how broadcasting works. Now you can see here we are creating a 4 by 3 dimension matrix with all zeros. Okay. Now we are creating another array, one dimensional array, rank 1 array with 3 values. So these 3 values are 1, 0, 2. Now what is the matrix name here? Start. And what is the matrix name here? Add rows. Now we are adding this matrix 1 and matrix 2 and storing it in object Y. In normal cases, it is not possible because the dimensions vary. But with broadcasting, it is made possible in NumPy arrays. Now when you display this, you can see that 102 is broadcasted to the first row, which gives you 102, and 102 is broadcasted to the second row as well, to the third row and to the fourth row, which will give you this result. Right? This is how broadcasting is done. Now let us create another 4 by 1 to broadcast across the columns. Here we have how many columns? 1, 2 and 3. Right? Now if you want to broadcast across the columns, let us create a 4 by 1 matrix because it has to meet at least this criteria of how many columns you have. In this case, those many columns should be available even in the broadcasting array. So you are creating another ND array 0, 1, 2, 3, right? And getting the transpose of it. How to get the transpose? Add columns is the array created 4 by 1. Now you have to transform that into column matrix, right? A row matrix now has to be converted into, here you are creating a row matrix. Now this row matrix has to be converted into column matrix. Now for that you are using transpose. Just use the matrix name dot t, which will give you the transpose. Now that transpose is stored in add columns and printed. Now you can see the column matrix 0, 1, 2, 3. Now this column matrix is being now broadcasted to this 4 by 3 matrix of all zeros, right? So when you perform that operation, you can see that 0, 1, 2, 3 is broadcasted across the columns, across all the columns, right? This is how you perform broadcasting operation. Now let us see some more examples for this. Here in this case, we are taking a single value and you can also broadcast in both the dimensions. Say you have a matrix like this 0, 0, 0, 0, 0, 0 and 0, 0, 0 like this. And you have just one element, 1 by 1 matrix. It has only one row and one column. Now, if you want to broadcast this not only across rows but across the columns, still it is made possible. You can just broadcast it across the rows and across the columns also, which will give you 1, 1, 1, 1, 1, 1 and 1, 1, 1. Okay, this is how it performs broadcasting across the rows as well as columns. Now you can see a scalar here, just one row and one column matrix, which we have created by using NP array. Now you're storing that in add scalar and you're adding it to the matrix. Now when you're adding this this matrix of single dimension will be broadcasted across the rows as well as columns. Okay, So this is how we perform broadcasting across the rows, across the columns, and across rows and columns also. Now you can see here some more examples. This is the 3 by 4 matrix that is created, and we are also creating 4 by 1 matrix, and we are performing broadcasting here, where you are broadcasting this matrix across all the rows of this matrix. So all these will be added. 0 will be added to 1, 1 will be added to 2, 0 again to 3, and 2 again to 4. Same operations will be done across this second row as well as third row. So when you execute this, you can see the operation. This row broadcasted to all the rows of this matrix. This is the result you get. Okay, in the next class, we'll see some more additional operations on these NumPy arrays.